In this section of Chapter 1, I would like to go over temperature scales, dimensional analysis, and homework problems. First, temperature scale. There are three temperature scales: Kelvin, Celsius, and Fahrenheit. The freezing point of water is 0 degree centigrade in Celsius scale, 32 degree Fahrenheit in Fahrenheit scale, and 273 in Kelvin scale. To be more accurate, it's 273.15. But for solving most of the problems, we're going to use 273. So in other words, if you just go by the freezing point of water, Celsius starts with 0, Kelvin 273 for the freezing point, and Fahrenheit is 32. And accordingly, when you convert from one temperature scale to another, you have to take into account these differences. In addition to that, in Kelvin scale, between 273 and 373, 373 is the boiling temperature of water. There are 100 divisions. So let me point out that this has 100 division for Kelvin. Same is the case with Celsius scale. So Celsius scale also you have 100 division. But that's not the case with Fahrenheit. In Fahrenheit scale is 180 division between 32 and 212. So that's 180 division. So the difference in these cases, especially between Celsius and Fahrenheit or Kelvin and Fahrenheit, is they not only they start with other than 0, also their divisions are different. And each division is called 1 degree in their own scales. So now you can see that why, in order to go from centigrade to Kelvin, you need to add 273, because everything else is same except the fact Kelvin scale starts with 273. By starts with, I mean at the freezing point, when freezing point of water is 0 degree in Celsius. So Kelvin is ahead of Celsius by 273, and that's why you need to add 273 to degree centigrade. In order to get degree centigrade, you have to subtract 273 from Kelvin. Now let's try to understand this conversion. Next one, degree centigrade from Fahrenheit. You can see that Fahrenheit, just assuming that number of division is same between Fahrenheit and Celsius, even though it's not same, let's assume for the time being number of division is the same. Then Fahrenheit scale is ahead of Celsius scale by 32. So in order to get to centigrade from Fahrenheit, first you need to subtract 32. Second, you need to take into account the fact that 180 division in Fahrenheit scale is equivalent to 100 division of Celsius scale, and that's where this 5/9 is coming from. 100 division of Celsius is equivalent to 180 division of Fahrenheit. So that's how you get 5/9. If you write down in a different way, degree Fahrenheit to be given by 9/5 degree centigrade plus 32. Plus 32 because Fahrenheit scale begins at 32, where Celsius scale is 0 degree. Now let's do one homework problem, which is number 25F. So number 25F, chapter 1. Okay, now question number 1 is, question number 25F say that 0 degree Kelvin, so 0 Kelvin equals to how many degree Fahrenheit? So that's the question. Now obviously Kelvin is given, so in order to get centigrade from Kelvin, you subtract 273. So first we are going to do degree centigrade will be given by 0 degree Kelvin, 0 minus 273. As I said before, we just ignored the decimal places. So I just wrote down as 273. So this is minus 273 degrees centigrade. Now we need to convert degree centigrade to degree Fahrenheit because the question is asking for Fahrenheit. So don't forget the question. So now what we need to do is you're going to use this expression at the bottom. So let's do that. So degree Fahrenheit equals to, remember 9/5 we mentioned 180 division by 100 division. So 180 division of Fahrenheit equivalent to 100 division of degree centigrade. So that's what incorporated in this expression. So 9/5 times degree centigrade, we already know degree centigrade, minus 273 plus 32. Why we're adding plus 32? Because Fahrenheit scale is ahead of Celsius scale by 32, even if their divisions were the same. So that takes into account that 0 degree Celsius is equivalent to 32 degree Fahrenheit. So once you do this math, you're going to get minus 459 Fahrenheit, minus 459 degree Fahrenheit. So that's the answer to this question. Now we're going to discuss dimensional analysis and go over a number of problems. You can see one of the sample ones where we're converting 8 meter to inches. 100 centimeter makes a meter. That's how we got this quantity. Then we know 2.54 centimeter makes an inch. So that's why we have it. Now we organized in such a way that we can cancel out some of the units that we don't want. So meter would cancel out, centimeter would cancel out centimeter, and finally we end up with inch. So basically we're going from 8 meter to inches, and that's the value. Now in order to convert from meter cubed to inch cubed, or meter cubed to inch cubed, or meter squared to inch square, we need to do a little bit more math. Especially when you square it, conversion values need to be squared too. Cube it, conversion value needs to be cubed. And I'm going to do a number of problems to show you that. Here I'm going to go over a density calculation, which is defined as mass over volume. And in order to explain that, I'd like to go over number 28A. So chapter 1, 28A. The question is saying that a cube of osmium metal having the side, each side is 1.50 centimeter and has a mass. So mass is given. So let's put down the values that are given. So mass is 76.31 gram. 76.31 gram, that's given. And obviously we can figure out the volume from the cube. So let me draw the cube so you understand. So this is the cube of osmium metal. This is how cube look like. A cube has same length, width, and height. And they're saying that it has the value of length of 1.50 centimeter. So it basically have 1.50 length, 1.50 width, 1.50 height. When you have a cube with all these three sides known, or any of these objects with three sides known, we can always calculate the volume. So in case of cube is the same value, same side length, so the volume would be given by 1.50 centimeter cubed. That means 1.50 times 1.50 times 1.50, and that gives 3.375 times 3.375 centimeter cubed. Make sure you understand that what centimeter cube means. Centimeter cube means you multiplied centimeter 3 times. So now we got the volume of 3.375. Now the question is asking for density value. So density is given by gram per ml. Now what is ml? Centimeter cubed is ml. So let me write down here, 1 centimeter cubed equals to 1 ml. 1 centimeter cubed is often called cc, cubic centimeter. It's the same thing. It's 1 ml. So now I can write down here 3.375 ml. So now I have all these right units. Let's separate these quantities. Now I can calculate now density. Density would be given by mass over volume. So mass is 76.31 gram. So 76.31 gram divided by the volume, 3.375. 3.375. And in this case, I mean, of course, question is asking for gram per centimeter cubed. So it's basically, we didn't need to change it to ml because it's the same thing. Sometimes they ask for gram per ml, sometimes ask for gram per centimeter cubed. So in this case, I didn't have to convert to ml. So let's have centimeter cubed. But even if you convert it, it's going to be the same number. So this is 22.61 gram per centimeter cubed. So that's the answer to this question. If they want in gram per ml, it would be the same number, gram per ml. So make sure you know that 1 centimeter cubed is 1 ml. Let's now try another problem, which would be 28C. In this problem, the density is given. So let me write down what is given. This is 28C, chapter 1. So density is given. I'm going to write down as D for density, and which is 0.8787. 0.8787, and the unit is written down as gram per ml. As you can see here, they have used gram per ml rather than gram per centimeter cubed. So these quantities are interchangeably used. So 8.8787 gram per ml, that's given. Calculate the mass of 0.1500 liter of benzene. So we need the mass. So the question is, what is the mass for 1.500 liter of benzene? Now I can see here, let's write down the volume so that we can think better. 0.1500 liter, 0.1500 liter. Now you can see that the units are not matching. One is liter, the other one is gram per ml. ml, either ml needs to be changed to liter or liter needs to be changed to ml. I think it would be easier or faster if you change liter to ml. So let's do that. It's just the conversion is 1000. 1000 ml makes the liter. So I can write down 0.1500. Let's write down here 1500 liter times 1000 ml per liter. It got a little bit messy here. So I have 1000 on the top and liter on the bottom. So that gives me 0.1500 times 1000, which is 150. So 150.0 ml. So basically I multiplied by 1000 to get it in ml. And I'm pretty sure that you know that. Okay, now let's get the mass value. I now know the volume, I know the density. So mass should be given by volume times density, or by purely following the dimensional analysis or following the dimension, you can come up with the fact that you'll have to multiply these numbers to get mass in gram. And we're showing you those units at the same time. So 150.0 ml. So let's write down here volume times density, and volume is 150.0 ml, and times density 0.8787 with gram per ml, and this gives you, make sure you double check my calculation, 1.318 or 131.8 gram, or 1.318 times 10 squared. So 131.8 gram is the mass, and that's the answer to this question. Let me now go over number 51 from chapter 1. So it's going to be chapter 1.51. So the question is that when the density of air is given, which is 1.15 gram per liter, so let's write down that. So density is given 1.19 gram per liter, so that's the given value. What is the mass in kilograms? So they're asking for mass. It's a good idea to write down given information and the information they're looking for. In kilogram, when in a room, the measurement of the room is given, so that's basically gives you volume of the room, which would be length, width times height. So let me do that. So volume would be given by 14.5 foot times 16.5 times 8.0. So these three quantities, length, width, and height. So 14.5 times 16.5 and times 8.0. That gives 1914 foot cubed. So that's the volume of the room, 1914 foot cubed. Now again, we're seeing that units are not quite matching because we have density in gram per liter, so we have liter there, but here we have foot cubed. So how do I go quickly from foot cubed to liter? That's I'm going to show you. From foot cubed you can go to centimeter cubed, and 1 centimeter cubed is 1 ml, then 1000 ml makes a liter. So that's what we're going to do. So I'm going to show you now the dimensional analysis part. So let's do that. So 1914, let's leave it outside of parentheses, 14. Now times, I have foot in parentheses and end parentheses. I'm going to end the parentheses with cube. So hope everything fits inside. So inside the parentheses, I need to change from foot to centimeter. And we already know 12 inches make a foot. So let's do that. 12 inch make 1 foot. That way foot would cancel out. I get inch, and cube is going to take care of inch cubed. but I need to go one more step because I need to get centimeter. 2.54 centimeter, that makes an inch. Now you can see now these units would cancel out, foot would cancel out, inch would cancel out. Now we're going to get centimeter cube now, and the value is 5.420. That's what I got, times 10 to the power 7. 5.420 times 10 to the power 7 centimeter cubed. Now centimeter cubed is same as ml, so let's change that to ml. So I'm going to write down here 1 centimeter cubed is 1 ml. That's the conversion value. And 1000 ml makes a liter. ml makes 1 liter. And this gives me 5.420 times 10 to the power 4 liter. So 5.420 times 10 to the power 4 liter is the volume of the room. Now I can easily now calculate mass they're asking for. So mass would be given by, I can draw a separating line. So we have volume of 1.19 gram per liter, 1.19 gram per liter, and then the volume 5.420 times 10 to the power 4 liter. Now why we selected like this? So the liter would cancel, and that gives me gram, but the question is asking for kilogram. We know that 1000 gram makes a kilogram, so that's going to be our next step. 1000 gram makes 1 kilogram. So now gram would cancel. Let me show you this cancellation. This gram would cancel. So we finally end up with kilogram, and the value is 64.50. So that value is 64.50, and that's kilogram. So that's the answer to this question. 64.50 kilogram is the mass. Let me now go over problem number 70 from chapter 1. So this be 1.70. In this question, they gave you density of water, which is 0.997 grams. So let's write down density of H2O, 0.997 gram per centimeter cubed. And gram per centimeter cubed, we all know that this is same as gram per ml, so it really doesn't matter as long as we know centimeter cubed is ml. So gram per centimeter cubed. They also give you the density of ice. Density of ice is 0.917. So density of ice is 0.917, and the value is gram per centimeter cubed. Centimeter cubed, and that's at ice temperature of minus 10 degrees centigrade. Now what they did is they filled a bottle. Let's draw a bottle to give you some kind of mental picture of this. Okay, it is not the best drawing, as you see this. and this bottle has the volume of 1.50 liter. So that's the volume. And they fill this bottle with water. So that means the volume of water would be same as volume of the bottle, because water completely fills the bottle according to the question. So the volume of water is 1.50 liter. Now the question is, when they're going to freeze it, what is going to happen to the volume of ice? Is it going to be same as 1.40 liter, less than that, or more than that? If it's more than that, we know that it's not going to fit in that bottle. So we're going to find out that. One thing you know, when water is frozen from liquid to solid, the mass doesn't change. So mass is going to remain the same. So let's first calculate the mass of water, the water that fills the bottle. So we're going to do that now. So mass is given by, let's separate the ice value for the time being. Mass of water would be given by volume times density. Of course, you have to consider the right units. 1.50 liter, since it filled the bottle, that's liter, times 1000 ml per liter. Now why we're changing it to ml? Because density is given in gram per ml, or gram per centimeter cubed. So your unit will have to be compatible. So now I'm going to use 0.997. That's the density of water, 0.997 gram per ml. So I'm using now gram per ml instead of gram per centimeter cubed. So that's same as ml, that's why. And here we can show you cancellation of unit when we write down as gram per ml. So let me show you these cancellations. ml cancels with ml, liter cancels with liter, and that gives me gram. So let's write down the gram value, 1.50. It didn't change that much because 0.997 is pretty close to 1. So you get 1.496. 1.496 times 10 cubed. 10 cubed gram. That's the mass of water that fills the bottle. Now when you change it to ice, again the mass is going to remain as 1.496. Now if you want to round off, because we had these three significant figures, it will become 1.50. So 1.50 times 10 cubed gram, if you want to round off. Now I want to remind you here by saying that mass of water, this is mass of water, this is H2O. Mass of H2O equals to mass of ice, and that's what we're going to use now. The mass of ice is going to be 1.50. Let's use a different color. So now we're going to use mass of ice. Now volume of ice times density of ice. Now mass of ice we already know is 1.50 times 10 cubed gram. Now volume of ice that we need to find out, so let's write down V. Density of ice they have given 0.917 gram per centimeter cubed, or let's write down as gram per ml. Okay, now it's simple algebra. Volume of ice equals to 1.50 times 10 cubed gram divided by 0.917 gram per ml, and this gives me 1.64 times 10 cubed ml. Or if you want to write down in terms of liter, divide by 1000, so that gives you 1.64 liter. Remember, the container, the bottle had the volume of 1.50, so this volume is increased to 1.64, so it doesn't fit. So the question is, first they're asking for what's the volume of the ice, that's in part A. What volume does the ice occupy? So this is the volume of ice, 1.64. In part B, so this is part A, what we're doing all these calculations is for part A. Now part B is asking for, will it fit? Can the ice be contained within the bottle? Answer is no. Ice will not be contained. So during the process of ice formation, volume is going to increase and some of the water would come out of it, and that's how it's going to happen.